So yeah, I mean, it's the last one. I appreciate you showing up. Sometimes when I teach a class in the last lecture, I give some tips how to study for the final exam. And I'm happy to say that I don't have any such advice for you today because we don't have any final exam. Yay. But you have maybe a 7th project to finish, perhaps. So I thought, I should really give them the answer to homework 7. It's 12. That's the answer. So just write that down, turn it in, you'll get full credit. There you go. Spoiler, I gave away the answer to homework 7. But no, I don't have any stuff like that to do with you because of, it's a little bit different structure to this class. So what I wanted to do today was I wanted to talk about something called React Native. And so I'll probably end short today. I probably won't go all the way to 250, but just, we'll talk about it a little bit and then we'll wrap up. So React Native is a very different way of developing apps. It's a framework that comes from Facebook. I'm just curious, how many of you have written code using the React web development framework before? 1, 2. Yeah, I certainly don't assume so, or I don't expect so. React is a framework that Facebook made to help them design web apps. And you've probably heard of some of these web frameworks. There were older ones called like jQuery and stuff, and now you have a lot of things like you have stuff called Node.js, and you have React, and you have all these different things, and web dev has gotten kind of complicated. I think if you want to be a software developer, you should take the CS 142 course, which is the web development course. And in that class, you do learn about some of these frameworks. I don't know if React is in CS 142. Have any of you taken that class? Do you know if React is covered in that class or not? I don't know if I can get to their website. What's the React.js? They do cover it, so it's in there. My guess is they don't spend a ton of time on it because they cover a whole other framework on the same lecture. So in 50 minutes, they cover it and another thing. So it doesn't look like they go super deep on it. But anyway, one thing that I think is kind of cool is that one of the designers of React was a student of mine at University of Washington, and I taught him how to code web dev, and then he went and made React after that. So that's kind of fun. Like if you do this long enough, I haven't accomplished very much in my career, but at least I know some people who have done some cool things. So I take credit for his work on React. Basically, I wrote it, is what I'm trying to say. Transitively, I did React.js, right? So no, I'm proud of their work. What is React? Like the thing is, there is this React web framework, and that's not what this is. This is based on that, though. It's a framework for developing apps that once you write a set of code one time, you can use that code to create an Android app, an iPhone app, a web app, a desktop app, a whole bunch of different types of apps, all from the same code base. And if you look back through history of coding, there have been a lot of initiatives that were sort of like this, where somebody would say, we should make it easy to develop an app that runs on lots of different architectures, And I don't know whether that really makes sense to you because a lot of languages now are sort of platform independent. If you learned Java, you wrote your Java code once, and if you had a Mac, it would work, and if you had a PC, it would work, and if you had different devices, it would work. A lot of times you can write the code once, but you at least have to compile it for the different OSs. But Java code, actually, the compiled version turns into this bytecode that runs on every different operating system. But it's still a pretty cool accomplishment that the same binary, the same executable program in Java can run on Windows and Linux and Mac and everything else. So typically speaking, it has been hard to create libraries for cross-platform application development. And some of the criticisms that are leveled against these type of frameworks is maybe they are slow or bloated, in order to make it work on all of them, it has to have this big, heavy code base. Another criticism is sometimes they sort of become lowest common denominator, because you could imagine if you wanted to have a feature that is in this framework that corresponds to some kind of widget or something, if that type of widget doesn't exist in both Android and iPhone, maybe you can't include it in this framework. Do you know what I mean? So it sort of feels like you can only include the intersection of these, and therefore the app that you build with this is not going to be able to leverage some of the unique, cool things about iOS or about Android. Now, this framework has a way around that where you can write most of the code as a unified base, and you can have certain specific parts just for Android, just for iPhone if you need to. So you can kind of get around some of these things. But anyway, I mean, I think the appeal here is pretty clear, right? I mean, like, you guys have spent 10 weeks learning how to write Android apps. You sort of know how to do that now. I mean, I'm not criticizing your studying. I'm just saying, like, there's more, right? You're not total experts, but you know some pretty good basics of how to do that. And nothing that you've learned carries over to iOS. Nothing, right? Like, maybe a few just vaguely conceptual ideas, but iPhone doesn't call their thing an activity. You know, I don't think they use any of the same languages or code bases or tools or technologies that we use at all. I think you can use Firebase and connect that to an iOS app, but the code for doing it looks different. And they use this language called Swift. And, you know, it's just like nothing you learned carries over, and that sort of sucks, right? You'd have to go take another class and learn how to do iPhone apps. And, you know, imagine you really want to make it big. You want to write a startup, an app that everybody will download and get 1 billion users and so forth. Like, you would need one for the iPhone and you would need one for the Android, right? You would basically have to write the whole app twice from scratch. The only part you could potentially reuse is what you might call the back end. Like, if you had like a data source, database, Firebase, something like that, that could be shared, and then the different apps could all connect to that. You don't have to have a separate database for Android or iOS. But short of that, you got to write the whole thing all over again. This is a real pain in the ass. And that's only for 2 platforms, right? I mean, Android and iPhone are basically the only 2 mobile platforms that matter. There used to be this thing called Windows Phone, but it kind of sucked, and so nobody has that anymore. And there used to be other things. There used to be this Palm Pilot and just different stuff, you know, and they're all gone except for 2. So, I mean, even just with 2, it's a pain. So that's kind of the impetus for like why somebody would want a framework like this. Yeah, go ahead, question.
Do bigger companies use React, or do they have like an Android and iOS development?
So I actually don't. I know there are some major apps that are written with React Native, but I would say the vast majority are not. So actually, I should have looked this up before class, but what major apps are written with React Native? Famous apps built with React Native. Some parts of Facebook use it, but not all. Walmart's app, some parts of Instagram use it. SoundCloud. So I mean, some major ones that you've heard of use it, but I mean, if I list all the ones that don't, it'll be 1 million, right? So it certainly isn't like a majority thing yet, you know? But hey, you could see why this would be appealing. If you could just write your app once, and then it would just work on all of them, that would be really awesome, right? So, okay, maybe this will help us to do that. If you use React Native, the unfortunate thing is that, like, it doesn't look anything like what we've been doing all quarter. Today we will not be using Android Studio. We will not be using Kotlin. We will not be writing any of the same methods and classes and libraries, things that you learned all quarter. Just the whole flow of how you do it is just very different. So, I mean, if I were really going to teach you this, it should probably be a completely different course, or we should back up to week 1 and just teach this whole course in that. You know, that would be another way of doing this. I chose not to do that. I think this thing, I mean, you'll see as we go along. I don't mean to keep teasing it without actually showing it to you yet, but like, I think this thing is cool, but maybe not quite ready for prime time. In fact, the current version of this has a number less than 1. It's like version 0.7 or something. So I think that's Facebook kind of signaling to the world, like, we're not quite done with this thing. Lots of people are still using it, but it's still being built up and changed a lot. So I think you still want to know how to write an Android app and or how to write an iPhone app. And then if you already know that, then this on top of that can be a nice thing to know. But I think if you don't know how to build the apps for each platform, it's sort of like you don't know what to Google for. You don't know what you're missing and stuff. So I think this works better when layered on top. In fact, I also, as you'll see, as we look at some of the code details, I also think it helps to have done some web dev, because this is done in JavaScript, which that's the language of web dev. And so if you've done web dev, you see things that look familiar from that context. And so, like, I think the flow that works the best would be like if you did a little web dev, maybe took a CS142 course, maybe even learned how to do the React library for web dev, did a little bit of Android dev like this class, and then on top of all of that, you went and learned this, then I think all the context would feel kind of familiar, and you'd like some of the familiarity that you saw. So anyway, that's the kind of the idea here, the motivation. Why would you want to learn this thing? So part of using this is you have to install it and set it up, and I really didn't want to like walk through all of that with you. They have a pretty good installation guide that's linked from the slides, or you can Google it. Their official website just walks through all the stuff you need to do. You have to install a lot of tools that it depends on. You have to install something called node.js, which is a tool that allows you to run a server on your computer or on some kind of computer, and that server software is built in JavaScript. So part of how React works is it runs a little server thingy that you connect to. So you have to install this node tool. You also have to have Java. You also have to have, you don't technically have to have Android Studio, but you do, and having it, you basically have to have an emulator, and the easiest way to have an emulator is if you have Android Studio. So basically, you should have Android Studio. You need some kind of text editor. You're not going to actually edit your React code in Android Studio. So I don't care what text editor you like Vim or something stupid like that, that's fine. Just kidding. But they have some that kind of work well, like this one called Atom, which is made by the people who made GitHub. It's a free editor, and it sort of like seems to understand React pretty well, so I like using that. That's what I will use. Mac people, I think, sometimes like this Sublime text program. Whatever, you have to have some kind of simple text editor. You have to install it. There's a bunch of things you can install to get this to work. So once you install these random things on your computer, then you actually do a lot of the work from the terminal, from the command line. And whenever I teach kind of early-ish courses, I know that a lot of students aren't very comfortable using a terminal. Like, we haven't taught it to them yet. Isn't it true that 107 is the class here that you learn that? Is that the only course where that's shown, or is there some kind of Unix, one unit course, sort of? Isn't there like something like 193 or? Anyway, whatever. Somewhere you're supposed to eventually learn how to use a terminal, and I'm just not going to dwell on that because I'm not necessarily teaching you this for mastery. Like, if you don't know how to use a terminal, you probably will have a little bit of trouble to run React. So, take 107 or something and learn how to use a terminal. But once you have finished installing all this stuff, from a terminal you can say React Native init, like initialize, and then you say a project name, and it does a bunch of work, and it will make a new project. That's how you create a project using this library. So I'm going to do that right now. I'm going to make a project, React Native init. I'm going to call this Berkeley. And it'll sit here and spin and run, and it actually takes kind of a minute. So I'm going to come back while it's running. I don't know how long it takes, but I'll just let it run. And basically, just from that command, all these starter files are set up for me, almost like when you have Android Studio, when you say new project, a bunch of files get created, right? A little structure of directories and stuff. And then you can edit the code, but actually you don't need to edit the code. But if you just want to test it, the first thing you do is you fire up your emulator. So just like you would have done with Android Studio, you launch your emulator. Then from the terminal, once the terminal's done creating the project, you type this command that says React Native run Android. And it looks like it's ready, so I paste and I say run Android. Wait. What? React Native. Sorry. It made a directory called Berkeley, so I have to say change directory to Berkeley. Then I say React Native run Android. The last time I taught this a year or two ago, and I legitimately couldn't get it to run. It just totally cratered any appeal the lecture would otherwise have had, because it's like, hey, look at this, doesn't work, And I'm sort of hoping that's not what's going to happen this time. But if you want to watch me fail, you can go watch a video from last time. But it's working, it's setting up. It takes a minute to get it going the first time, but you'll see it's not so bad once it's set up, So that is one thing, I'll say, this might seem like it's slow, but one of the things people like about this tool is that once it gets up and running, it's actually pretty fast to play with it and test things and change things and refresh, and I'll show you that. Isn't that one of the worst things about Android Dev? It's like you sort of run your code and it doesn't totally work right. So you go back to Android Studio, you change 2 lines, and then you hit the play button again, and you have to wait for like an hour for it to actually update the stupid fucking thing, right? This tool is not as slow as that in terms of the like edit refresh cycle. So I think it's working now, and if I go here, it says it's loading. I guess it's still loading up. I'm a little worried. I don't know if I have like bad Wi-Fi being in this room. That's another thing. I don't know if it'll harm anything. I think it's still loading up or something like that. But in a few seconds, I'm going to have a screen that says like, "Hello, this is your app." There, yay! Welcome to React Native. To get started, you can edit this file named app.js. Double tap R on your keyboard to reload. Shake or press menu for dev menu. So it's funny because if you're testing it on a real device, you can go and it'll pop up a menu. It's called the Rage Shake. Well, look here. Let me try to. I don't think I've convinced you at all that this is neat yet. So let me show you one thing that's neat. Okay. So it says edit app.js. So like if you go, I have this program installed named Atom. So it's just a text editor. But one thing I like to do with this editor is you can say like open folder, and I'll browse to my Berkeley folder here. And I'll say, okay, open that. So now it sort of views that folder as kind of the starting point. Now remember how the emulator said to edit app.js? I know the font's a little small, but if I double click that file, now don't get scared, there's a bunch of weird stuff in here, but like you can see how it says, double tap R on your keyboard to reload, right? Like this text is this text, right? So if I just said like, on your face, lol, 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 to reload. I edited the file and I saved it, okay? And if I go back here, and if I press RR, it just like refreshes it. And so like that whole cycle of edit it and run it again is like really, really, really fast in React Native, which I think is very nice. And the editor itself, you know how Android Studio, when you first want to load up Android Studio, you can basically go like, take a shower and a shave and come back and it's almost done loading and all that stuff. Like, I mean, I can just close this thing. Oh no, I closed it. You ever accidentally close Android Studio? No, this time it's due in 45 minutes. I don't know if I can load Android Studio back up in 45 minutes. Well, Atom's pretty fast. It just, after a couple seconds, Atom should be back on the screen here. So, I mean, this is all like pretty lightweight dev tool stuff once you get it up on the screen, okay? So, maybe you're slightly intrigued at this point. Do you have any questions so far? I mean, obviously I have not explained anything about this code. I will talk about it, but kind of so far, any questions about React Native? Okay, well, I ran some command a minute ago where I said run Android. I've never tested a React Native on iPhone, but like if you have a Mac, and you either have an emulation of an iPhone device, or you physically have one you can plug into your Mac, you could run a similar command that says run iOS, or I think it is something like that, and then it'll test that app on that platform as well, using the same code that I will edit today. So that's pretty cool. Okay, so back to slides. Also, like I'll talk about it later, but like you can pull your app out and you get this APK file that you can, if you actually want to take the app and give it to people and stuff. But okay, so what's going on in a React app? I tried to strip out, like the file that it made for me is the file necessary to create that screen that we saw a minute ago. But I really wanted the like minimum possible React app that would run, that would do anything. So here's kind of the basic structure of a React app. You start your app by importing things. We'll talk about what those things are in a minute. You have to write a class that is for your app. You have to use inheritance to extend something called component. And then inside that, you have to write a method called render. This is the syntax for writing a method or function. And that function returns a set of widgets that represents your app or your screen. And so I'm returning something that contains a text widget that says hello world. And so what's kind of weird about this code here is like everything except line 9 is JavaScript code. So the language we would use if we were going to actually write an app this way is JavaScript language. So separate question, how many of you have ever written any JavaScript code before? Okay, some. Again, it's okay if you haven't. I mean, I don't think today's lecture is meant to cover that language in detail, but JavaScript is, it's a fairly concise, high-level language that's used when you write web pages with interactive code in them. They're always going to have that code be in JavaScript, So most of this is JavaScript code. However, React has this special magic feature that's called JSX. I think it's just like JavaScript extension or something, where in the middle of JavaScript, you can switch to a different syntax that looks a little bit more like HTML or XML or something like that. So, I mean, if you just want to try to map what you've learned in this class to today, it's like most of the rest of this code is your Kotlin file with your events and your behavior and your logic and stuff. But then this little part is where you write what would have been in your layout XML file. So it just sort of lets you, in the middle of this JavaScript code, it kind of lets you switch into a mode where you're writing this other kind of syntax with tags and attributes and stuff. And I think what it does is when you compile your program, it sort of walks through and it does a bunch of magic conversion of something into something else. And I don't know kind of what it does, but that's a minimal React app. Let me show you a little more about it, because I think the more we see, the more it will make sense. So the code that you're writing is JavaScript. It's technically something called ECMAScript, which is sort of the latest, greatest, newest version of JavaScript. If you write web apps, your web code, your JavaScript code gets executed in a user's browser, and different people have different browsers, different people have different versions of browsers. So a big thing you have to deal with when you do web programming is you have to worry about what features are available to the user's browser. So you might want to use some feature or some library in JavaScript, but it might not be there because the user has some old-ass computer. Now you might say, "What? I thought the browser auto-updated and stuff. Isn't everybody on the new version? Why wouldn't you be using the new version?" There's lots of people using a work computer that's been locked down and it doesn't install automatically the new update, or they just have an old version of an operating system that doesn't get the updates anymore. There's a lot of reasons why they might not have the newest version. So that's a thing that you have to worry about when you do web dev. In React and in this mobile dev context, you do not have to worry about that. So basically, React is always using the sort of newest, coolest JavaScript features that are out there. So I mean, whatever. If you're not an experienced JavaScript programmer, that doesn't mean anything to you. I'm just letting you know that if you do know some JavaScript and you see some stuff here that you haven't seen before, you might be like, "Oh, I didn't know JavaScript had that operator or that keyword or whatever." Well, it does, or it will, but some of the browsers may or may not support that yet. So whatever. But you write an app that's a class, that's a subclass of a thing called component. And a component is either a widget or an activity or a screen or something like that. And components can contain other components. You know how in this course, we've learned about writing a little layout XML that gets inflated, like that flag lecture, where you sort of take a few widgets that are kind of related to each other and make a little thing out of them, and you inflate the thing. That would also be called a component in this context, as well as a whole activity, like a whole screen would be called a component. So your UI is expressed using that sort of XML syntax called JSX inside of JavaScript code. Okay, that's kind of the anatomy of what's going on here. So this slide is just a list of all the different components that React supplies. There's a set of common components that work on every operating system. They're guaranteed to be present. And then there are some that are specific to individual operating systems, that maybe that OS has a particular feature or paradigm and so forth. So you can use these other ones, but you have to sort of do some checking for operating system before you use them. I am not going to go into all these in detail. I think a lot of them are somewhat intuitive. You go, "Oh, there's a button, it's a button." There's an image, you could put an image on the screen. There's a text control, that's for text view, for displaying text. There's a text input, that's basically an edit text. So you can look these things up and see how they work. And if you click on one of them here in the slides, there's a documentation of kind of how they work. But we're only going to use a couple of them today. So one thing that happens pretty quickly when you're writing a React app is you decide you want to have styling. You want things to look a certain way. This is also used when you want to manipulate your layout. So the way you do styling is, there's two different ways. One way is when you have a view on the screen, you can specify individual style properties that it has. Like you could say it has a blue background color and a yellow foreground color. You could just say that this button has this or this view has that. Or you can say this view is in the awesome style, and then somewhere later in your code you can say things that have the awesome style have this background and this color and so forth. So that would be useful. This latter style is called style sheet. This concept is also present in web development. You might have heard of CSS or style sheets from that context. This is more the style that you'd use if there are several widgets that have the same kind of style. Like all the buttons have this color and this font. You set them all to have a certain style class, and they all reuse that. So just let me show you real quickly. If you look at the little baby app that we wrote here, or we didn't write, but that React spat out for us. So here's what the code looks like. It says we have a class called app, and the only contents of that class are a render method, which returns this. So it's got sort of an overall external container, and inside of that there are three text views, basically. The first one says, welcome to React Native, so that's this. The second one says, to get started, edit this file, that's this. And then the third one is, it says instructions in brackets, and instructions is a variable that's declared up in the code. So I think that the starter code they're giving is also kind of meant to give you a little bit of a tutorial, like in the text of a widget, you can refer to variables from your code, and it'll insert the value of the variable in your code. You have to surround them by curly braces. So this thing up here is some sort of string. I mean, frankly, I'm not an expert at React Native, but I think what's going on here is that if you're in iPhone, it'll say press Command R to reload, and if you're in Android, it'll say double tap R on your face to reload. So whatever, but that's what's being returned. But I wanted to talk about styles. So if you look here, it says style equals styles.container. So if you scroll down here, underneath the rendering code, there's a thing that says const styles equals style sheet create. And so down here it's creating these different styles, like anything that has the container style has these properties to it. Anything with the welcome style has these properties to it, and so forth, right? And of course I haven't gone through all these different things and the syntax for them and whatever, but I would guess that a decent amount of it is self-explanatory, that you'd say, oh, font size 20, I think I know what that means. Text align center, I think I know what that means. Like this thing that says welcome to React Native, I bet if I change that to say left and then I go back and I press RR, maybe I misunderstand something. I bet if I set this to 40, let's try that. There, now it's got really big. We'll talk about why that didn't go to the left in a second. But I mean, you can edit these properties and it changes the way that it looks, right? Instead of saying, styles.welcome, you can do what I had on the slide a second ago, and you could do this thing called inline styling, which is where you just put two brackets and you just put the style properties right in there instead of having it refer to something down below. And then I think if you refresh that, it's blue with yellow text, so whatever. Those are the two ways you do styles. More common is to do this style sheet way here. Is that clear? Do you have any questions about this general setup that it uses here?
How do you decide that what's going to be the exact location of that particular text view or whatever you?
How do you do the exact, more precise location of where things will appear? Yeah, I'll show you that in a second. I mean, basically some of these styles down here have to do with justification and alignment and this thing called flex, and all that together I'm giving it instructions about how to position everything and how to size everything. So down in the style sheet you're going to describe things about layout as well as like fonts and colors and stuff. Okay, so I'll show you that. I think it's right up next, coming up. So I already showed you style sheet example. So let's talk about layout. This is a case where if you've done web development, this would be easier because web dev has this layout engine called the Flexbox. It's no relation to the mediocre video game console. It's a system that allows things to be laid out in rows and columns, and you can specify which things flex, which things resize based on various properties that you give. It has a lot of similarity to Android linear layout. Now some of you, I actually don't know, when you make a new app, the default layout is the constraint layout, where you say this is attached to the right edge of that or something, and this system isn't really written in that way. It's more like linear layout, where you say it's a row or it's a column, and this thing has a weight of 99 so it stretches a lot, and this thing has a weight of 1 so it doesn't stretch a lot, and you sort of allocate space using that model. So I'm not going to give you a good tutorial or a really complete listing, but I just think we'll play with it a little bit. So this screenshot here, it's a little cut off, but this here is you can't really see the code very well, but you make a view that has 3 views inside of it, and a view is just an empty space, it's an empty area. And if I say one of them has a flex 1, flex 2, flex 3, it's like saying weight 1, weight 2, weight 3. So like it allocates the space by adding up the total to 6, and then it allocates 3 6 to this guy, 2 6 to this, and 1 6 to that. And then it also applies those background colors and stuff. So, I mean, I guess to answer your question was if you want to lay things out, you sort of specify views that have flex properties of various kinds, and it'll sort of stretch and pull your widgets into the right place. I honestly haven't coded with this system as much as I've done with other systems, and so for me, I sometimes have to try it 2 or 3 different ways before it works. But you know, the good news is that this is pretty similar to web dev. So if you've done web dev or if you go on to web dev, this will kind of carry over to that context as well. And we'll come back to this, but I guess sorry. Let me talk about why did this thing not go to the left when I said text align left here. I think what it sort of means is like if the widget were wide, where would the text be within that? So I think if I said like width, 90% or something. Oh, it doesn't let me do that? Okay, maybe, one thing that's confusing about this system is not every widget accepts every property, but whatever. If you say you want to align items like left up here, I think that will work. Uh-oh. So I didn't want to talk about this, but yeah, when you get errors, they pop up over here now in your screen here, which is kind of fun. But you can't say left. It says you have to use flex start, flex end, center stretch, or baseline. They call left start and right end. I think we talked about this very briefly before in Android. Flex start. Let's try that. So it's on the left now, whatever. It calls it start and end because certain people read right to left and they want to work well for both ways and stuff. But anyway, so let's look at some more examples. Here, I tried to come up with an example where I just wanted to move some widgets around, like kind of to answer your question. Like how do if I want this widget here and I want that widget there, like how do I do it, So this doesn't cover everything you might want to do, but here's an example. This is a 2-part code example, so some more code. The style sheets are on the next slide. But what I've got here is I've got an outer view that covers the whole screen, and it's going to be colored in this kind of yellowish, I don't know if it looks more like tan for you guys, color. And you don't see very much of that on the screen. You only see it here. You'll see why in a minute. But inside of that is a sort of pinkish container that you see the pink along the top there, right? And it has button 1 and button 2 inside of it. And also below the pink container is a green container that has button 3, button 4, button 5 in it. And then button 6 is not inside of any particular nested container, and he's at the very bottom. So I guess like the question would be like, how do I make those tags look like this? The answer would be the outer container, I set the background to that yellowish color. The split horizontal container, which is at the top, the pink one, I set it to be a row instead of a column. I tell it to put space between the widgets. I tell it to have a red background, and I tell it to take up 100% of the width of the screen. So it sort of stretches out, and then the 2 buttons inside are spaced as far apart as they can be. The middle container, which is the centered H container there, it's another row. It's justified to the center without the space between. It aligns its items to the center, and it has a green background, and it's stretched wide as the screen. So, I mean, that's just an example. If you drew me a bunch of complicated pictures, I might have trouble to make some of them look exactly that way in Flexbox, but like this is the general gist of it. Rows and columns and stretching and alignment and stuff, and that's how you make your UI, okay? So whatever, that's about the best I got. But we don't need very much layout today. We're not going to cover like all this crazy stuff in great detail. Okay, so let me tell you a bit about how to make your app have behavior. Like once it loads up, once it looks a certain way. Or actually, I tell you what. Let me reorg how I want to do this real quick. My goal here is I want to go back to where we started. Remember the first lecture, the good old days when when you didn't know any Android, and we did this very first app of 2 numbers, and you have to pick the bigger one, and if you get it right, you get points, and then you get to go to Berkeley or whatever, right? Of course, if you want to get into Stanford, it's just a cash deposit app that sends the money to the crooked team coach instead. So they could probably make fun of our admission more this week. But whatever, let's not talk about that. But I want to write that in React. That's a decent goal, right? In one lecture of React, we can do this equivalent program. So maybe since we learned a little bit about how to lay things out with Flexbox and some of these widgets and stuff, maybe we could make it look like this, and then we'll talk about how to have the event handling when you click on the buttons and stuff, okay? So let's look at the code here. Now, you got to kind of bear with me, because I realize, like, you barely saw this stuff, you don't know JavaScript. I mean, it's just like, I know this is kind of a stretch, but if this is the code for the app, let's just go one by one. So we want the top that says bigger number game, right? So maybe I'll change this, I'll change this to say bigger number game. And for the style for this, I think it used to say styles.welcome. So this Atom editor, it doesn't do a great, like, you don't get red underlines if you have a syntax error or whatever, but it does kind of autocomplete, sort of. So that's kind of nice. So it says bigger number game, and then it says press the button of the larger number. So maybe here I'll just write press the button of the larger number or whatever. I'm not going to type all that stuff out. Then there's two buttons, and then there's a thing at the bottom that says points, right? So at the bottom, there's a text that says points. I guess initially you have 0 points. And then there's these two buttons. Well, I haven't shown you buttons yet, but guess what? You put button. The text that goes on the button is written as title equals. So maybe I'll say 0 for them both. So there's my UI. I know it kind of is hard to see. It scrolls off the screen or whatever, but that you could use that as your starting point for your UI. If I go refresh this, can't find variable button. I know that's the right name. Do you have any guess what I have done wrong here? You need to import button. I mean, if you didn't know that, that's fine. It's just up here somewhere. You're importing all the different widgets like style sheet and text and view, and I need button. Anyway, it's okay if you didn't know that. I mean, you haven't seen this before. But if I refresh, bigger number game. It looks perfect, doesn't it? So let's try to make it look a little more. I don't want it to look perfect or whatever, but let's try to make it look a little more like the original app we had, right? So first of all, I think this alignment, we can say center. That would help a little. So how do I get the bigger number game thingy up here and this thing down here? Like, how do I, any ideas how I might approach that?
Is there a way for you to bias or locate, like welcome in the welcome style sheet?
So in the welcome for this bigger number game, if I could say go to top or something like that. Well, so I think that, yeah, I see the instinct of like, can I say go to north, and for this guy, can I say go to south? I think the right mental model here is like, you want to think about like who's stretchy and who's like trimmed tight to size. And so what's happening right now is the overall screen has this container style, and the container style is the whole screen, okay? That's everything. And that container style is seen down here in the code where we have justify to the center, align to the center, and so forth, okay? It takes up the whole screen. So it centers everything in it. Now, then the things in it want to be this tall collectively. That's like how big they would like to be. So if you don't want them to be mushed in the middle like that, you'd sort of like some one of these things to ask to be taller than its normal size. So if you told, let's say, this guy here to make himself be really big, that would push the other ones down and so forth. So you can do tricks like that. Or if you don't want to stretch the widgets themselves, you could put them inside of a view that stretches itself. So like the way I think of it is I want the text up here that says like bigger number game, blah, blah, blah. I want that up here. And then I want this sort of big middle area. And then at the bottom, I want the little thing that says points, blah, blah, blah down here. So, if I want to get a big old guy right here that eats up most of the space, maybe between the bigger number game here and the points here, I want to insert some sort of view. Oops. And this view is going to like eat space. Now what's going to be in that view? It's going to probably be the, press button or these buttons or something. I mean, maybe it goes underneath this guy. I don't really want this guy to stretch. But like what if I said style equals styles dot big one? And if the big one is a style that has a flex property of 99, then he's probably going to eat all the space, Now, where is he? He's empty. He's eating all the space right here. If you don't see him, I guess I could say background color red. I think I have to put it in quotes. Oh, does that not work? Oh, I think I need to say width 100%. I think he's like infinitely narrow because there's nothing in him or something. I don't know. This stuff is hard, like you do it the first time, you don't always get it right. But like I got this big in view here that's eating space but doesn't have anything in it. So you can do stuff like that, like there's a lot of different stuff you could do. I kind of wanted these two buttons to be in the middle of that though, not all the way down here. So maybe I'll actually put these buttons inside of that, and I mean, I don't want it red, but I'll fix it in a minute. Now they're up there. They're still part of the red guy. It's just that their blueness covers the redness. I think if you look, there's a teeny pixel of red peeking out between them, so they're in the red zone there. If I want these guys to be on the edges instead of mushed like that, how do you think I do that? We can look at these slides. Where were they? Come back. This thing. So, like, if you want stuff to stretch out, this is a pretty similar example where these guys are in this split horizontal container here. That guy with the red background, I could make him have properties like this. I could say he's a row, put space between the widgets, and make him 100% wide. So that'll sort of make it do what I want. So if I go back here and I say this big one, his flex direction, is that what it's called? Flex direction? Yeah, flex direction. Flex direction is row, and the justify, I always have to look up the names of these things, justify content to have space between it. There. So now if I do that and I refresh, well, nice big buttons you can click on here. But anyway, like, I want you to see, like, this is sort of the process by which you make this thing look a certain way, right? I don't know if I really care about the buttons past this, but maybe I'll make this font slightly smaller, the welcome, maybe I'll say 30. So there, that fits now, or whatever. Okay, I want to like get to more. I don't want to get stuck here. So like we'll fix this in a minute if we have time with these giant tall buttons. But you can kind of see how this process goes. You sort of slice it up. You sort of put views inside of views. If you need this stretching here and this stretching here, you solve that by nesting views within views. Okay, so that's layout. Now let's talk about if you actually want the code to be interactive, you want events, you want the code to do stuff. How do you do that? Well, that's going to be more of this JavaScript code. And the JavaScript code, there's a little bit of syntax I want you to understand, that if you have a JavaScript class, you can have a constructor, and you just write the word constructor, and then you put some statements after this super call. And that would be where you'd set up any sort of initial stuff related to your app. And then if you want to have other functions, you just don't even say fun or function or void or anything. You just write the name of the function with parentheses, and then you write the statements you want to run. And what we will use those functions for will mostly be handling events. We'll say if you click this button, call that function, right? That sort of thing. Yeah. So okay. So now what? What do we put in these constructors or functions? Well, a big part of dealing with an app is that the app has state. I mean, if you go all the way back to the first lecture, the Berkeley game sort of had different pieces of state. Like there was a number on the left side, there was a number on the right side, and there was a certain number of points the user had earned, and if you click, it would look at the numbers and add points or take away points. So there's like 3 or 4 like variables that the app had that it was keeping track of. In our code in Kotlin, that was private var variables or something like that. So in React, you have this notion of state. And so the way you declare state is that in your constructor, you say this dot state equals, and then in curly braces, you write name and value pairs, variable name and value, variable name and value. If this syntax looks sort of kind of vaguely familiar to you, like where have you seen syntax sort of like this before? JSON, because this is a JavaScript object with fields that have values. JSON is literally just declaring JavaScript objects and sending it to you as data. And so that I'm declaring a JavaScript object here. This is JSO, but it's not JSON. Anyway, whatever. You don't go up and say private var or something. You don't declare the fields up there. You just set their values in the constructor, and then they will exist. They will be there. So like if we were going to write the Berkeley guessing game, this thing, you'd sort of have up here in the class here. It doesn't currently have a constructor, but you could say constructor, you have to say props. This is in the slide, you copy this. You say super props. Super props to you guys for sticking with me this long. Then you say this dot state equals, and then you write a JavaScript object. So maybe the state of the app is like the number on the number on the left is 0, and the number on the right is also 0, and the points you've earned is 0. That's your state at the start of the app, okay? That's all you do. Now, just doing that isn't going to lead to any behavioral change that we would see on the screen, but that's a start. So the next step after you sort of decide what your state is that you can refer to the state in the JSX, like XML type code. You can refer to it, you can use it. And so like, for example, this button here that says 0, or this one that says 0, I could go back here and instead of saying 0, I could say bracket, bracket, and inside there I could say this dot state num left. The number on the left is in that first button. And for the one on the right, I could say this dot state num r. Now, you might say, wait, what's the point of doing that? Because there's 0, and it already said 0 in the code before, so why change it from 0 to some variable whose value is 0, right? What's the difference? Well, one of the wonderful, magical, awesome things about React is if you modify these variables, the UI will notice and it will update itself automatically right away. This is called data binding. You're basically saying, I want to bind the displayed value of this button to be connected to this variable. And so it's like watching the variable. And that's really cool. I think one of the design philosophies of React, I mean, you guys have just written several apps that were graphical, right? And isn't it true that you get into this state where like you've modified some variables and now you need to take those modifications and then like tell a bunch of guys about it, like, hey, text view, update yourself, hey, button, change your text, hey, you, do this, do this, do this. And it's like annoying because you kind of have to remember which widget needs to be told, and sometimes you have the right private var state, but then your widget is wrong and they're out of sync with each other and stuff. And it's not, I mean, the assignments you guys have been doing are somewhat small, so maybe you haven't encountered like horrible problems with this, but you can sort of imagine keeping like some sort of internal data in sync with like a UI display of that data. That's kind of a generally tricky thing, right? React is trying to address that by having your UI be sort of declarative. You sort of explain this button should always show the value of num L, whatever that is. This button should always show the value of num R, whatever that is. This thing down here should always show how many points I have, however many that is. And in fact, I'll just do that. Instead of saying points 0, I can say points bracket this dot state. What did I call it? Did I call it points? Yeah, points. So again, they all will start out saying 0, but in the JS code up here, if I modify these guys will just redraw with the new state. That's pretty neat. Does it make sense so far? You got a question about that? I mean, I'm not doing anything to update these yet. They're just getting set in a constructor and never changed. But that's where we're going to go next, right? So, I mean, like if I go back and refresh this, I hope I didn't break anything. Uh-oh. Invariant violation. The title of a button must be a string. So I think here, like it's trying to inject this value, and it's an int. So, like, I forget, can I just wrap this with quotes? Or, I mean, I have to convert this int of this num_l into a string. I don't think I can do that. I think what you need to do is you need to say quote plus there. So, like, convert the int into a string variable. Let's try that. There. So, okay, that doesn't look very cool. It looks the same as it looked before. But if I set these to like 2 and 7 and 45, and then I reload the game, it should draw 2 and 7 and 45, right? And so, like, okay, these things are like synced up to each other. Cool. Now, how do I make it so that these things change? Well, the next step is you want to set up event handlers. Like when I click on the button, I want it to call a function. So like the typical way of writing a function is you just write its name, like left click. And so this will be, you know, when the user clicks the left button. And maybe there's some function called right click. And so I just want to set it so that when you click these buttons, it'll call these functions, right? The code for doing that is a little bit silly, but it's not that bad. What you do is you say on your button, you say on press equals, and then in brackets you write this dot functions name dot bind this. Like, what? It's a little bit dumb. I mean, whatever. But like, you follow this template where in the button here, after you're done declaring what the title of the button is, instead of saying kaboom, I would say like left click. And for the other button, the one on the right, I'd say right click. I mean, I think this is bad. Like, I wish it was just like on press equals left click. That's what I think it should be. They did not consult me on the matter, so you have to say that. But that will call these functions. And you can do whatever you want in here. I'm going to make it so that these functions will update these variables and stuff. But maybe just for a second, if you just want to pop up a quick message box, you can just say alert left. And over here, if you want on the right, you can say alert right. So that's equivalent to a toast or a, I guess it's more like a dialog box. But if I double reload and I hit this, it says left. Okay. Right. Okay. So like, it's calling my functions here, right? So what I actually want to do is modify these things, right? So let's do it. If you want to compare this number to this number, you can get these out. You can say var left equals this dot state num_l. Var right equals this dot state num_r. Now again, like I apologize, we're coding in a language you might not know, but I hope the logic is not too confusing to follow, right? So if you click the left button, you're saying you think the left one is bigger, right? So if the left value is bigger than the right value, hooray, you got it right. So maybe var points equals this dot state points. If the left's greater than the right, points plus plus, right? Else points minus minus. Now that alone is not enough to update the screen, because I guess the way of thinking of it is like I sort of pulled this value out of the state and then I updated a copy of it. I didn't actually update the state. So you might think that the way to finish this code would be to say like this dot state points equals points, like put that variable, that copy back in there. That's the right idea, but that doesn't quite work because React sort of wants us to be more clear that we're updating the state of the app. And so the way that you tell it that is you call a method named setState, and in brackets you pass key value pairs of which state you're updating. So it's the same concept. So you just come back here and you say set state of points to be equal to this variable. So that set state will see that the variable has changed, the state variable has changed. It'll notify any widgets that are bound to that variable. And so I could, redundancy is a separate issue, but I could have very similar code for the right click. I apologize, this is horrible. Don't copy and paste code. But really what you want to know is if the right one's bigger for the other button. But if I run this and I say, which one's bigger? I think 7 is bigger. Uh-oh. Cannot find variable set state. I think the reason is I think I'm supposed to say this dot set state. One thing I always forget in JavaScript is that if you want to call methods on your own object, in a lot of languages if you just say foo, it means like this object call the foo method. But in JavaScript you have to say like this dot every time or else it doesn't work. I'm pretty sure that's what I've got wrong. Let's try again. So yes. See, look at that. If I click the 7 is bigger than 2. So my points are going up, and if I click 2, 2 is smaller, so I'm wrong, so it's going down. Of course, I'm not updating the numbers and stuff, so I think if I want to do that, I need to like re-roll the numbers. So I think what I want to do here is I want to write a function called like update nums or something, and maybe if you pass me the number of points, then I'm going to re-roll the dice to pick new values, like var left equals math.random times 10, and I want that to be an int, so you have to say parse int. This is stuff you don't know from JavaScript, but I'll sort of re-pick the two numbers, and then I'll say set the state to be number on the left is left and number on the right is right, and the points equals the points you passed in as a parameter. So here I'll sort of say this dot update nums with this many points, and also I'll do it in the right click here. I think that'll do the trick. Let's try 7. So I think it's working, right? The bigger one's giving me points. If I pick the littler one, it's going down. The code isn't even that good because it didn't check for ties. Like, this is worse than the app that we had before. But that's like pretty much the logic of that app is pretty much working here. And I apologize. I realize I'm like throwing a bunch of stuff here that you haven't seen these languages and these tools and stuff. But I think that the point is not for you to really learn the JavaScript language or even to really learn this framework in detail. But I'm just kind of trying to show you this programming model. Like, it sort of has this state-based model where the widgets refer to things from the state, and if you update the state, the widgets figure out that they need to redraw themselves. That's a pretty cool idea in this framework. Do you guys have any questions so far about the code that I just was hacking on? Yeah.
What if you find passing points as a variable again? Like you have to, when you set state, you have to reset all the state variables, or can you just omit points since you already updated it?
Well, so I guess what I could have done is I could have called set state of just points up here, and then I could have updated the numbers as a separate thing down here. But I just decided to, like, this is a local variable of the new amount of points, so I decided to send that in and then sort of randomly repick these guys and then just set all three of them in one swoop, I guess. I think you could split that into two parts, set the state of the points, but then I think what it would do is it would like redraw the screen with the new points, and then like immediately it would redraw the screen again with the new numbers, which I just thought of maybe that's inefficient. Maybe I should tell it to set the state just once. I don't think it would have hurt anything, but I don't know. And to be honest, I'm not an expert at this framework, and I have heard that if you do a complicated React app, dealing with the state is like a thing that you have to think about. And like I think there are these add-on libraries that go on top of React. There's one called Redux that's pretty popular. That is a state management library, and I couldn't tell you what that does because I haven't really used it very much, but like it kind of helps with this a little bit more, some of this stuff. I think some developers feel like state stuff is tricky, and so they want help with that, so this library kind of helps them manage that. But I just wanted you to understand the kind of the model of what it's doing. Any other questions so far?
So you could just run the line of code you showed before to get an APK, and then you could send, like basically you could just send this to an iPhone and an Android and work on both?
Well, so there was a line of code on one of the earlier slides that shows that this also generates like an APK, which is an Android app packaged up into a single file. You can take that and send it to somebody and they can install it on their phone, or that could be the basis of an app that you submit to the App Store or something for realsies. That file does not work as an iPhone app, But if you go back to your terminal and you say, instead of saying run Android or whatever, I typed run Android. If I were running on a Mac and I said run-iOS, I think, it would generate the equivalent. I don't know what the file name would be, but it would generate the file for an iPhone app. And so you would now have, this as an app for both of those operating systems if you wanted. So, I mean, look, yeah, I think if this is a tough sell here and you're like, I don't know, what the heck is this stuff? This is weird, right? This is not what I learned for the last 10 weeks. I want to go back to happy familiar land with Kotlin and stuff. Fine, that's fine. I'm not claiming this is a better way to write Android code. I am claiming that this code will run as an iPhone app, which is, in some argument, better than slightly cleaner code that only runs as an Android app, or just cleaner being subjective, right? So that's the appeal here. Not that this is somehow way cooler model for GUI programming or whatever. I also wanted to say, if you've done web dev, this React framework for the web is also pretty similar to this in terms of how it looks. And so if you learn web dev or you learn this and you go to the other context, you can carry a lot of that over. So that's pretty cool. Anyway, that's most of what I wanted to show you about React Native. Let's see, do I have anything else I want to say? Events. Yeah, that's mostly it. So yeah, I mean, I don't know what your takeaway is. Like, I have had this thought, in terms of me, I'm the only one who teaches this class like once every year or two, and I have thought, like, should I just go back to the start and just teach this as a React Native course and not teach an Android development class, And I mean, there's some argument for that, right? Like, maybe you guys would be happier if you're like, I can code for both operating systems now. I'm not just an Android. I mean, because you may have had this conversation where you talk to some friend of yours and you're like, yeah, I'm taking this Android class. Look, I made a Snake game. And they're like, wow, can I run that on my phone? And you're, what kind of phone do you have? And they're like, an iPhone. And you're like, oh, sorry, I can't help you there. In fact, I was telling my mom, bless their heart, my parents were like asking me about what class I'm teaching. I was explaining the mobile app, Android class. And my mom, bless her heart, she pulls out her phone and she's like, can you show me your class programs on my phone? Of course, she's got a fucking iPhone. I'm like, sorry, Mom. And then she's like, what about you, Larry, to my dad? And my dad also has an iPhone. So it's like they were like visibly unimpressed with my class after that, right? So it kind of would have been cool if I was like, well, they could code their apps and it could run on every mobile operating system. I mean, that might seem like an interesting way this course could have gone direction for this class, but I feel that this thing is still not uniformly better than knowing how to do it the real way. I think that knowing the real way and then maybe adding this on top could be a way to do it. I don't know. There was there was a React Native class that was taught. I think it was like Stanford React Native class. I think it was CS92 SI or something like that. Is that right? No, maybe it's not here. CS92si.stanford.edu. Does that work? No, that's Python. Wait, why did that send me there? There was a class taught once by a grad student that was a React Native class. And I thought, I should talk to him and compare notes with him. But my sense was that React Native was not quite ready for prime time yet, that they're still kind of working on it. There's still some issues with it and stuff. There's also some other frameworks that are in competition with this. Like, it's not entirely clear that this is the one and only framework for doing cross-platform development. There's another platform called Flutter that's made by Google, and it's the same idea. You write the code once, and then I don't know, something like this. You write the code once, and then it outputs an Android app, and it outputs an iPhone app, and so on. So some people got really excited when Google made their own multi-platform framework. I decided it was crap because the language it uses is called Dart. And Dart is a language that Google made up to replace JavaScript, and like nobody used it. And so I think they're sort of hoping that this framework will save their language that nobody likes. And bless their heart, I don't think it's going to happen. But anyway, there's other frameworks like this that you can use for cross-platform development. So like, I wouldn't want to invest in making a class on one unless I was pretty sure it was like the one that was going to win the battle or something. But anyway, I wanted to show it to you because I do think if you guys ever want to make a mobile app for real, you have to think about, like, how am I going to build this, and what if it's only for Android and my iPhone friends can't use it? What am I supposed to do? You know, so it's a tough question, and this could be a good answer to that question. So I'm basically wrapping up. There's lots of stuff I didn't teach you. One topic I didn't really show you was, like, what if you make a real app and you want to submit it to the App Store? I didn't show you that partly because I don't have a ton of experience doing that. I haven't submitted a lot of apps to the App Store. Also because you can kind of just Google it and follow instructions and tutorials and stuff. You have to do some stuff that's a little bit of a pain, like you have to submit it for approval. You also have to do this thing called signing your app. You have to get like a security checksum like key thing attached to your app to make sure nobody tampers with it, so that when people install it, there's no potential that they're installing some sneaky bad version of the app that spies on them or hacks them or something. And so there's kind of some muck and some detail to it. And the other problem is, like, as a lecture demo, I can't submit it and then get a response back from Google in time, you know? So it's like I can't do it and then say, look at the App Store, guys, I'm there. You know, like I can't like demo it live. So I would say if you do want to do that, don't be discouraged. Don't think that's out of scope. Like if you just search for like, how do I submit an app to the App Store, I think that you would be able to understand how to follow the instructions to do that. So anyway, I'm basically done. You know, I want to say I appreciate all you guys for showing up and coming to class, and I enjoyed having you in this course. And I also appreciate. I wanted to thank the CAs, Ashley. They're not here, but then maybe I'll watch them in the video. Ashley and Gracie and Sarah and Shreya. They did an awesome job. And so, you know, good luck on your homework 7 and on all your other finals and stuff. And thanks a lot, you guys, and have a good spring break and stuff. Thank you.